Hello and welcome to another WJEC A level physics question. This one was question 5 from the June 2014 Unit 5 paper. And it's about electron beam in an electric field. And this is work that's in Unit 4 in the current specification. So what we've got is an electron entering midway between a pair of plates of a parallel plate capacitor, effectively. It doesn't mention capacitor. Oh, it does mention capacitor actually. And it's moving horizontally to the left at 8 times 10 to the 7 meters per second. We've first of all got to show that the vertical acceleration of the electron is approximately 2.6 times 10 to the 14. And because it's a show that question, we're going to be very clear in our workings. So let's go through the algebra bit by bit. The first thing we could do is we could work out the electric field strength by taking the potential difference between the plates and dividing it by the separation of the plates. Next, we could calculate the force on the electron by using the electric field strength times the electron's charge. And then finally, we can calculate the acceleration of the electron by looking at the resultant force on the electron and dividing it by the mass. So altogether, we have this for the calculation, where E again, as we did at the start, was V over D. So now we can put in the figures. V is 11.2 volts, the electron charge 1.6 times 10 to the minus 19 coulombs. The separation of the plates 7.6 millimeters, turn the millimeters to meters, and the mass of the electron 9.11 times 10 to the minus 31 kilograms. When we put those figures into a calculator, we end up with 2.59 times 10 to the 14. Which is very close to the 2.6 that we had to show. For the next part of the question, we've got to explain why the horizontal speed of the electron remains constant. Well, basically, that electric force would be an upward force on the electron, because the electron is negatively charged and is attracted to this positively charged upper plate. And if we have a vertical force, it has zero component in a horizontal direction. So basically we can simply say here that there are no forces in the horizontal direction, or no forces horizontally. Next, we're asked to explain why the vertical acceleration of the electron is constant. Well, the acceleration was calculated using the electric field strength, and the electric field strength between the plates of the capacitor is uniform. So let's just put that down. The electric field strength is uniform. Next, we're told that the electron enters the plates and travels a horizontal distance x before hitting the top plate, and see the diagram. And we've got to calculate x. So what we're going to do here is we're going to treat this as we would a projectiles question from AS Physics. So if we're looking at the vertical direction, if we take upwards as positive just for argument's sake, and think about what we know. We don't know the final velocity of the electron. Vertically, the electron is moving with an initial velocity of 0. Even though it's moving horizontally at 8 times 10 to the 7 meters per second, its vertical initial velocity is 0. Vertically, it travels half the distance between the plates, because remember this electron started halfway between, so we got 3.8 millimeters. The acceleration was the 2.6 times 10 to the 14 meters per second squared, and the time we don't know. So we're trying to find a horizontal distance, so what we're going to do is first of all use these data for the vertical motion to be able to find t. So we'd be looking for the equation that doesn't have v in it, so that would be x equals ut plus a half at squared. The ut bit is 0, so this simplifies to x equals a half at squared, and hence t is 2x over a, all square rooted. So t will be square root of 2 times 3.8 times 10 to the minus 3 over 2.6 times 10 to the 14. And that will give us 5.42 times 10 to the minus 9 seconds. or 5.42 nanoseconds. Now we can look at the horizontal motion. Horizontally there's no acceleration, so all we need to do is apply v equals x over t horizontally. The horizontal distance x is vt. v was 8 times 10 to the 7, which we got over here. And t is at 5.42 nanoseconds. If we put that together, we get 0.43, give it an extra figure, 0.434 meters. The final part of the question asks us to calculate the extra kinetic energy gained by the electron before striking the plate. Now you can do this in long-winded ways. You can calculate the final vertical velocity of the electron and work out how much kinetic energy it's gained that way. But a very, very much quicker method is to realize that if the electron starts halfway between the plates, it's starting at a position where the potential is half of 11.2 volts, in other words 5.6 volts. And it moves to a potential of 11.2 volts, so it moves through a potential difference of 5.6 volts. And when an electron moves through a potential difference of V volts, it gains that many electron volts worth of energy. So we can simply write down here, the answer would be 5.6 electron volts. Note that the question doesn't ask for an answer in joules. If it did, we can multiply that by 1.6 times 10 to the minus 19. Thank you very much for listening. Please remember to like and subscribe and feel free to answer any questions. Goodbye.